Okay, hi class. Assalamualaikum warahmatullahi wabarakatuh. So now let's continue on the voltage regulator part. So as explained before, why you need voltage regulator, because your input here is a variable sources. Your aim for chapter 3 is to convert AC to DC, right? So your output need to be a straight line. So in order to have a straight line of the DC supply, you need what we call voltage regulator. So what will be the function of voltage regulator? To supply a constant voltage to the load. How we can have this constant voltage? Because of the Zener diode is having a Zener breakdown at what we call Zener breakdown voltage. The name is VZ. So this VZ will provide the constant voltage to whatever load that you connect to the voltage regulator. So let's see the first example. So in this example, there are three elements. One is the supply, another one is a resistor, and the third one is the Zener diode. So in order to do this, so we need to have, here will be connect to plus, and when your Zener diode is connected to plus at this line of the Z here, means it operate at the reverse bias. So when we are having, this is Zener diode, right? So if we have the voltage connected here plus and plus, so it will happen at the forward bias. So it's like a normal diode. But when it start to connect like this, so this is your Zener diode. When it start to connect from here, it connect to plus. So here plus and here also plus. So this will happen at the reverse bias. So when it happen at the reverse bias, we have what we call Zener voltage, that is VZ. So first we need to have the KVL equation. So what it will be the KVL equation? Minus Vs plus RID plus, okay, since this Zener diode is operate at the reverse bias, so we need to have here Vz equal to 0. So your Vs is, the peak value here is minus 12 plus 10k ID, and Zener voltage is having a constant voltage. So here is 10 volt. So you can get the value of your current. Okay, so let's see how is the voltage regulator circuits looks like. First, your input here from your VPS is a variable. So it can be maximum or it can be minimum. And then it will be connected in series to a RI. And then you will have what we call Zener diode here, where it will operate, since it is plus and here is plus, so it will operate at the reverse bias condition. Your Zener diode will be parallel to your load, and here where you're going to measure your load voltage. Okay, so since this Zener diode is operate at the reverse bias, so at this condition, it will have the voltage here will always be Vz. Why Vz? Because of the property of the Zener diode. At the reverse bias, it will have Zener breakdown. So number one, Zener diode will hold the voltage. What voltage that it will hold is what we call Vz, regardless whatever current goes into the Zener diode. So if let's say your Vz here is 10 volt, here will be always 10 volt. Why? Because of the property of the reverse bias, it will hold the voltage regardless of the current from the supply. So when here is Vz, since your Zener diode is parallel to the RL, so due to the concept of parallel circuit, your Vz will be always equal to the load. So the load resistor will see a constant voltage regardless of the current. Why? Because your VL here is parallel to your Vz. Okay, so let's say the VS here is maximum. The remainder of the VPS will be absorbed by your resistance. Okay, so from the same circuit like before, so let's derive what will be the value of your Ri here. So first, we have the KVL equation here. So your Zener diode will be operate at the reverse bias because here is plus and minus. So this Vz will play role here. So from your KVL equation, minus VPS starting from here, plus Ri, II, plus. So at your Zener diode, since it is reverse bias, you can directly take the Vz equal to 0. So take out your Ri, move the rest to the right, so it become Vps minus Vz divided by II. So what is II here? Okay, so II here is the total current from the R in. So by applying the KCL law, so this is II, current entering this node. Let's say the node here is A. So what will be the current leaving the node? Is the current across the Zener diode, that is Iz. And then you have another current here, that is IL across your load. So by using KCL equation, current entering equal current leaving, right? So you become I total equal Iz plus IL. So this will be second equation. The R in just now will be first equation. So what you need to do now is to combine equation 2 to equation 1. So it become R in equal Vps minus Vz divided by Iz plus IL. So this will be your main equation for your voltage regulator. Okay, so just now, why you need voltage regulator? Because your VPS here is having a fluctuate value. So remember the output from your filter is having ripple, right? So this ripple is having V maximum and V minimum. So since you have maximum and minimum, so you need to make this voltage constant, means the output here is a straight line. So therefore, in this equation, you have two conditions where what will happen when your VPS is maximum and what will happen when your VPS is minimum. Okay, the important condition here, when your VPS here is maximum, your Iz current will follow your supply. So means when VPS maximum, your Iz will be maximum. And due to this KCL, when this is already maximum, this will be the inverse, right? So means your IL here will be minimum. What happens when you apply the minimum value of your VPS? Your Iz will follow to become minimum and your IL will become maximum. So this is two conditions for you to apply to this formula. So we have two formula here. The first formula is VPS maximum. What will happen to the Vz? Vz is a constant, so you don't need to change anything. So now your Iz here become maximum. Why? Because it will follow your VPS. Whatever happens here, it will follow. So when VPS maximum, Iz will become maximum. And then your IL will become minimum. This will be equation 1. Equation 2, what will happen when your VPS equal minimum? Your Vz is a constant divided by your Iz will be minimum and your IL will be maximum. So your Iz will always follow your VPS. So with these two equations, depend on the question, if it give any value, so you can plug in from both of the formula. But on top of that, you need one extra formula from the question where you are going to assume Iz minimum is equal maybe 0.1 Iz maximum. So this will be depend on the question given. So if we give condition, you need to replace this one into equation 1, 2 and 3, and then you can solve the question. So we will see the first example after this. So the summary of the voltage regulator is here. So this is what is the condition that I mentioned just now. So when your VPS is minimum, Iz will follow, and this one will be maximum. When your VPS is maximum, Iz will follow, and the other one will be minimum. So you're having one condition of VPS minimum, another condition when VPS is maximum. To solve that one, you need this equation depend on the question. So you need to remember this formula. So the last part is the question will ask what is the maximum power dissipation of your Zener diode, that is PZ. So what is the formula for power is IV. So Vz is a constant value. Iz you will take the maximum value. So Pz equal Iz maximum multiplied by Vz maximum. So this is how we are going to derive the equation for voltage regulator. So example of the question. So is like this one. So I will explain these examples in the next video. So in the conclusion for voltage regulator, what you need to know is the formula of Ri and then the formula for Pz. So we will discuss this example in the next video. Okay. So that's all for today. Assalamualaikum warahmatullahi wabarakatuh.